Professor S.S. Mantha, Shankar S. Mantha, the previous former chairman of AICT for 2 consecutive terms, and a distinguished academician as well as actually administrator to have with us. He has got an illustrious career that spans over 4.5 decades. Dr. Shankar S. Mantha has held several important positions both in academics as well as public administration. He was the former chairman of National Regulator AICT and implemented several e-governance initiatives and facilitating regulations over 6-year period. He was also the president of National Board of Accreditation for 3 years. Earlier, Professor of Robotics. He was Professor of Robotics and Control Theory and AI at famous institution in Bombay, Victoria Jubilee Technical Institute. He currently is the Chancellor of Ramdev Baba University at Nagpur. He has more than 285 publications in national and international journals and conferences, besides authoring 3 books. He is the author of National Vocational Education Quality Framework, which is now referred as National Skill Qualification Framework, and the regulations for blended learning. He was member of Karnataka Skill Development Authority and advisor to the government of Andhra Pradesh. Earlier, he was the Pro-Vice Chancellor of SNDT Women's University, the Chancellor of KLA University, each of which he served for 3 years. Further, he served as a CEO of Mahaprit Startup Knowledge Center of Government of Maharashtra for 1.5 years. He is also the adjunct professor at the National Institute for Advanced Studies, NIAS, Bangalore, and chairman of Technical Committee, National Cyber Safety and Security Standards, and IT expert for the government of Maharashtra. So it is very heartening to have him here today, and his lecture is going to be on AI in education, in which he himself is an authority. Now, here we have also some of our corporate, institutions, and I can see here the Vice Chancellor of SOA University, Professor P.K. Nanda. I would like to request him to say a few words.
Thank you,
Nanda,
sir.
please.
Sir, thank you, sir. Good afternoon. Esteemed Chairman of INAE, Chapter and Chairman of our Advisory Board for University, Professor Damodar Acharya, distinguished fellows and members of INAE. Today's speaker, distinguished speaker, Professor S.S. Mantha, and our coordinator, Professor Renu Sharma, Additional Dean. On behalf of SOA, I welcome all to this distinguished lecture series. We are happy to be associated with the INAE Bhubaneshwar chapter for this lecture series. And our university is quite proactive in organizing conference, workshop, seminars, lecture series, and other activities. University this time is ranked at 14th position as a university category, 24th among all institutes. And we are also conducting conferences regularly. We have also have a SOA fortnight lecture series conducting, which on special theme of the subjects in every year, like marine technology in last year, and this year knowledge system we are conducting. So we are very happy to be associated with this kind of series, technical series, which is very good. And I thank chairman of our advisory board for grouping in very distinguished personalities in their respective areas to deliver or share their expertise with all of us. Thank you very much.
Do you have anybody else?
Hello. Hello.
Hello.
Hello. Am I audible?
Yes, sir.
Hello.
You're good.
But the camera doesn't seem to come on. So,
Yes, sir. Your camera is off, sir.
yeah, the camera is off.
May I now request Professor Manthar to deliver his address?
Yeah, I can do that. The camera
Professor
seems to
Manthar,
be
your
off.
video is not working.
Yeah, the video is not working. That's what I'm looking at. So can you see the presentation?
Yes,
Yes,
sir. We
yes, absolutely,
Yeah.
it's fine.
Yeah, thank you so much. And I'm sorry for the
No,
the-
that's the problems are there. It's nothing to worry.
yeah.
Please.
So I'm making it full screen, so you should be able to see the full screen.
Yes. Full thing
Yeah.
actually you are able to see. No
Right,
issue
right.
at all.
So we first of all thank you for the opportunity to speak to all of you on AI in education. What I'll do is go off the track a little with bringing in parallels between the human intelligence, artificial intelligence, and how it relates to the Hindu philosophy. Now, and the applications obviously will be in education, since we are talking about the artificial intelligence and its role or its effect in education. Now, it's important to integrate technology and human expertise. Dharma is something that I have brought in, and empathy in educational settings. Now, having said this, what is human or artificial intelligence? For example, we must first of all define what is intelligence. Then we talk about human intelligence. Then we talk about artificial intelligence. And then we talk about applications in AI. Now, vriksha sita surajishu nityam sandram rasam tad vrittimanya sada para prakrutim. Vriksha sita, wherever there are trees, there is nature. Nityam sandram rasam, that nature will give create the happiness or the ecosystem that sustains all of us. Nityam sandram rasam. Tad vrittimanya sada para prakriti.
The slide is not changing.
Yeah, I have not changed. One second.
Okay. Thank you.
So tad vrittimanya sada para prakritim. What it really means is anything other than nature is artificial. So therefore, we must be one with the nature and not be artificial in our relationship to the nature. Now, the agenda with an Indian perspective is we will talk about human intelligence, human sensors, how is intelligence built, the human brain, what is the artificial brain, the man-made sensors, how is intelligence measured, AI and its relations with AI, and then how does it correlate with the Sanskrit in terms of natural language processing. Then we have ChatGPT models, generative AI, how similar to how intelligence is measured, human intelligence is measured, how do you measure artificial intelligence, the Turing test, and then the applications AI in education and things like that. So first of all, when we talk about human intelligence, we talk about the cognitive abilities and the skills built around that. So as far as the memory is concerned, it is the capacity to store, retain, and recall information and so on. So we have short-term memory, temporary storage. We have long-term memory, which is the ability to store information over extended periods. And we also have the working memory, which is active processing and manipulation of information. So that's about memory. The second part of cognitive ability is also the attention. So you have selective attention, you have divided attention, and you have sustained attention. Concentrating on a particular object while ignoring irrelevant information is selective. Managing multiple tasks simultaneously is divided attention. And then sustained is maintaining focus on over prolonged periods. The third part of cognitive ability is perception, the process of organizing, identifying, interpreting, and things like that. Then we also have problem solving, decision making, which are part of our cognitive abilities. Having said this, when we look at the structure, we have two important parts here, the Broca's area and the Wernicke's area, which are interrelated. And the to and fro information flows, for example, vision, hearing, touch, is Wernicke's area. And you have Broca's area, which controls the rest of the things and the motor functions and so on. So you get a frame of the picture around us, and then it creates a continuum which lets us, configure different pictures in our brain. Now, in order to do all that, we need the senses. Obviously, the 5 major sensors: sight, taste, hearing, touch, and so on, and smell. Now, when I go back to senses and intelligence, what does it mean in terms of senses, our human senses and the intelligence? Indriyani paranya harindra param manaha manasastu para buddhi dhiryo buddhe parasasa. The senses are superior to the body. Indriyani paranya. The mind is superior to the senses. Harindriyebhya param manaha. The intellect is superior to the mind. Manasastu para buddhi. But the one who is superior even to the intellect is the soul or the consciousness. Buddhe paratastusa. Now this also tells us the senses interact with the external world. The mind processes, or the manas controls the senses, and the intellect governs the mind by making decisions and guiding actions. Above everything else, we have consciousness and so on. When we talk about human intelligence, now it has multiple facets. Self-awareness, self-regulation, motivation, empathy, social skills. These are all part of emotional intelligence. Originality, fluency, flexibility, elaboration, they are part of creative intelligence. Adaptability, being street smart, application, applying the knowledge that we have in different scenarios, is the practical intelligence. All this put together becomes a part of human intelligence. Then we have linguistic intelligence. We have verbal skills, we have communication skills, we have logical and mathematical intelligence, numerical ability, logical reasoning, and so on. Spatial intelligence is visualization, spatial reasoning, and so on. Musical intelligence is rhythm.
Slides are not moving.
It's now human intelligence facets.
Yeah, the first one only is visible. After that,
Okay.
now it is fine.
Okay. So we have here, I am on this. Yeah, when I make it full screen, there is some problem again. Okay, so in human intelligence, there are multiple facets, like I was telling about. We have linguistic intelligence, logical, mathematical intelligence, spatial intelligence, musical intelligence, and also kinesthetic intelligence, physical coordination, motor skills. They also form a part of the human intelligence. Besides that, we have interpersonal intelligence, social interaction. We also have, you can see the slide, I believe. Interpersonal intelligence, you have neuralistic intelligence, naturalistic intelligence, you have moral and ethical intelligence. Integration of multiple intelligences happens, and cultural and societal influence also creates certain amount of intelligence. So these are the multiple, facets of intelligence. Now coming back to human intelligence again, buddhir brahma vidyabhihi mana sankalpa yogataha praveshami janana buddhi sada pradipita. Buddhi Brahma Vidyabhi. Intelligence is illuminated by the knowledge of the absolute. Manas Sankalpa Yogata. And through the act of contemplation. Sarvesham hi jananam buddhi. For all beings, intelligence, sada pradipita, is always enlightened. So therefore, this emphasizes the connection between intelligence, human intelligence, knowledge, and the importance of contemplation in enhancing human understanding. Now let's go one step further and now talk about human sensors and how they are related to human intelligence. This is built on sensory input processed by various types of receptors in the body. So some of the receptors I'll be speaking about here. You have photoreceptors, location, retina of the eyes. Function is detect light and enable vision. What are the types of photoreceptors? We have rods and cones. We have mechanoreceptors in the skin, ears, muscles, tendons, joints. We have in types, we have tactile receptors, baroreceptors, proprioceptors, and hair cells in the inner ear. They are the human sensors. What I'm trying to do is create a parallel between what are the human senses and what are the artificial senses in the next few slides. Then how do we build the intelligence around the human system, and how do we build intelligence around the artificial system? So these are the hearing mechanics. Then as far as sensors are concerned, there are many more. There are thermoreceptors on the skin. There are functions is detecting change in temperature. Types are cold receptors, warm receptors. Chemoreceptors you have tongue, nose, brain. And function is detect chemical changes. You have gustatory receptors located in the taste buds on the tongue. So you get to know the taste, sweet, sour, salty, and so on. Olfactory receptors you have located in the nasal cavity, which detect the smell. You have central chemoreceptors located in the medulla, detect changes in blood pressure, blood pH value, and carbon dioxide levels. And then you also have peripheral chemoreceptors located in carotid and aortic bodies, detect changes in the blood oxygen levels. Further, we have nociceptors. Location is again skin, muscles, joints, and some internal organs. Function is detect pain. Thermal nociceptors respond to extreme temperatures. Mechanical nociceptors respond to physical damage, such as cutting or crushing. And chemical nociceptors respond to chemicals released by damaged tissues. So we come to know whether there is pain, whether there is extreme temperature, there is damaged tissue. We all know these from these sensors. Further, we have electromagnetic receptors. Location is non-prominent in humans, but includes photoreceptors. And function is they determine the electromagnetic fields. There are many other specialized receptors. Osmoreceptors located in the hypothalamus detect changes in the osmotic pressure of the body fluids. Baroreceptors, they tell you the blood pressure. Stretch receptors found in various organs like the stomach and bladder, they detect stretching and the fullness of those organs, and that is how we feel a need to eat. We feel hungry or not hungry, things like that. These are because of stretch receptors. I have given you a diagram here which functionally shows you how these receptors are spread in terms of the human brain. Now, how is intelligence built? Various receptors. Now, we have seen several human receptors. Now, these receptors provide the brain with a continuous stream of information about the internal and the external environment. So you have sensory input, perception and cognition. You have feedback mechanisms. Continuous feedback from sensory receptors allows the brain to adjust and optimize on responses, leading to improved learning and adaptive behaviors. Every one of this is a feature of artificial intelligence. That's the reason I'm going through these initial steps. Development of skills through sensory experiences, individuals develop various skills, including motor skills, language, social interaction, and critical thinking. Right from the time a child is born, this knowledge is gained by inputs from various sensors, and later on they translate into higher orders of intelligence. We also have emotional intelligence, that is again sensory input from social interaction, facial expressions, tone of voice. In machine learning, the higher levels of deep learning, machine learning, and so on, we also have systems which are where a lot of research is being done into creating systems which have emotional intelligence. So our receptors play a fundamental role in gathering sensory data, which is essential for building and enhancing human intelligence. And the brain's ability to integrate and interpret this information leads to the development of cognitive abilities in human beings. Now, conscious human intelligence has 4 parts, like you see here on the left side, left top, 5 senses, which build the state recognition. Unconscious function and conscious thinking is built by and done by real-time analysis. Accurate execution will create body movement, and autonomous decision will be reaction and insight. On the extreme right, if you see, the system algorithm, the human system algorithm probably be something like this. If sense, organs consider X, meet the threshold, then body execute the effect, else remain the current state. Now, this is how the human system operates. Now, besides the human intelligence, besides receptors, there are many other things that build our intelligence. It's built through a combination of genetic, environmental, developmental, and experiential factors. Genetic factors are inherited. Brain structure and function is influenced. Early development, prenatal environment, neurodevelopment, environmental factors, these are all important besides the receptors to build our intelligence. Now, how is intelligence developed in a different perspective? The metaphysics of that says, Vidya dadati vinayam, vinayad yati patratam, patratvat dhruti santoshaha, santoshat buddhi sampada. Vidya dadati vinayam, knowledge gives humility. Vinayad yati patratam, from that comes worthiness. Patratvat dhruti santosha, from worthiness arises determination and contentment, and santosha buddhi sampada. From contentment, the wealth of intelligence is built. So when I say the intelligence is developed besides receptors, what we mean is this. And the shloka highlights the process through which intelligence is built, emphasizing the importance of knowledge, humility, worthiness, determination, and content. There's a lot of information that comes from the receptors, but besides that, you need all these attributes. Now, the human brain is very complex. The structure and organization has major regions with specialized functions. So we have cerebrum, cerebellum, brainstem, and limbic system, out of which most of these things we must be aware. The limbic system is something which is extremely important in terms of correlating it with the artificial intelligence system. Now here, I have tracing oxygen consumption. The brain accounts for about 20% of the body's energy consumption, despite only representing 2% of its weight. That's around 0.3 kilowatt hours per day for an average adult, more than 100 times of what the typical smartphone requires daily. Now, where does all that energy come from? Let's see. So there is the limbic system actually tells us the entire, structure of the brain. And at the center, you see the cortex. And cortex is something that is important in terms of its relationship to artificial intelligence. Otherwise, the diagram shows you the different sensory organ, sensory senses and its organization, which is the limbic system. Now, if I go to the next one, this is more interesting. The cortex region is made of multiple layers. If you take a cross section of that, you have molecular layer, you have external granular layer, external pyramidal layer, internal granular layer, and so on. So there are multiple layers that define the structure of the human brain and its cortex. Why is this important? Because artificial intelligence also depends on the multiple layers, which is the middle layer in an artificial intelligence model. Then we have, when we talk about human brain, we have neurons and synapses. Primary functions are neurons, specialized cells that transmit information via electrical and chemical signals. Neurons consist of a cell body, which is called soma. Dendrites receive signals, axon which sends signals. So one is a dendrite is a receiver, and axon is a transmitter. Now, synapses are the junctions between neurons where neurotransmitters are released to transmit signals to other neurons or larger cells. Now, that is about the construction part. How does the communication happen? There are electrical signals and there are chemical signals. Action potentials are electrical impulses that travel along the axon of a neuron. And chemical signals are neurotransmitters released from synaptic vesicles in the presynaptic neuron and cross the synaptic cleft to bind with receptors. Besides these two, besides the construction and the communication, there's a functional part of the network. Different networks in the brain are responsible for different functions. Exactly the way brain is structured, the way we have tried to define artificial intelligence. We'll see that in further slides. So the functional network is different. Networks in the brain are responsible for various functions, like I said. So you have a sensory processing, you have motor control, your cognition, and emotion. These are all controlled by different networks, which are actually layers within the cortex of the brain. Now here again, the bulk of the energy is consumed at the synapses. If you see this is the synapse. The bulk of the energy is consumed at that, and the tiny gaps between brain cells where signals are sent and received, they are actually called as the synapses. Now there is something very interesting here. The human brain is very green. Adult human brain runs continuously, whether awake or sleeping, on only about 12 watts of power. For comparison, a typical desk computer draws around 175 watts and a laptop somewhere around 60 watts. Now, why is this interesting? This 12 watts of power that a human brain consumes is constant. Whether we do high-level philosophical thinking, reasoning, or we do a low-level activity, the 12 watts of power remains constant. Whereas in a computer, in a typical desktop or a laptop, as the functions change, the power that is drawn also changes. This is a huge difference between a machine and a human brain. Now, human brain also displays plasticity. There is synaptic plasticity, which means changes in the strength of synapses based on activity levels. Structural plasticity is growth of new connections and changes in the structure of neurons. That is how it optimizes the power that is required to do various kinds of work. Now, then we have autonomic functions. Homeostasis, maintaining the body's internal environment, the temperature, the hunger, thirst, these are all maintained by autonomic functions. And the brain's stem is responsible for that. Within integration and coordination, the brain integrates information from various sources and coordinates appropriate responses. That is crosstalk between hemispheres and the feedback loops that it creates. Now, this is something extremely important from a human brain perspective. And this is exactly how we also build the artificial intelligence. Now, let's see. When we talk of brain and its functions, if we go back to Bhagavad Gita again, Smritishcha chittam cha manaha, prajna cha vivekatam, ekatritani yatrani tatra buddhi sadasthita. Smritishcha chittam cha manaha, memory, mind, and soul. Prajna cha vivekatam, intellect and discernment. What is right and what is wrong? Vivekatam. When united in harmony, ekatritani yatrani, tatra buddhi sadasthita. When united in harmony, the mind, memory, mind, soul, intellect, discernment, when all this come together, their intelligence remains ever steadfast. Now, all those functions that we have talked about in the earlier slides, it comes back into this shloka that we have. It highlights the interconnected aspects of the human brain, memory, mind, and intellect, and their role in sustaining intelligence. Now, having looked at what the human brain is all about, now we will look at artificial brain, and we lead to artificial intelligence, and then the applications. Artificial brain is a complete set of software and hardware with cognitive abilities similar to those of animal or human brain. These AI models are based on neural networks and are often structured in ways that are inspired by the human brain, which is what I've been talking about. What are the basic units? Biological neurons in human brain, artificial neurons in AI. What are biological neurons? They are the basic units of computation, and they receive, process, transmit information through electrical and chemical signals. Artificial neurons in AI models or nodes are the fundamental units, and these are the nodes in the structure, in the network. These neurons receive input, apply mathematical transformation, and produce an output. There are connections within the human brain. There are connections within the AI. Synapses is in the human brain. Weight is in the AI. So neurons in the brain are connected by synapses, where neurotransmitters are released to transmit signals. That's the human brain. In neural networks, connections between artificial neurons or those nodes in the network are represented by weights. And these weights determine the strength and influence of the signal passed from one neuron to another. There is a layered structure of the brain that I spoke about. The cortex itself is layered and it stores different functions, higher level functions, and so on. Human brain, particularly evident in the cerebral cortex, where different layers are responsible for processing different types of information. Cerebral cortex is organized into 6 stacked layers in the human brain. It increases the computational efficiency of the human brain. Now let's see what happens in AI. Layered architecture in neural networks or artificial neural networks also have a layered structure, architecture, which includes input layers, hidden layers, which are the intermediate layers that transform the input into something that the output layer can use. And obviously, there are also output layers which produce the actual result. So there is a layered structure of the brain, the layered structure in AI, and now how does the signal transmit, and how does it get activated? There are action potentials in human brain. Neurons in the brain transmit signals through action potentials, which are electrical impulses that travel along the axons, the transmitters. Now, activation functions, artificial neurons use activation functions like sigmoid, rectified linear unit to introduce non-linearity and determine the output of a neuron given in input. So there are action potentials versus activation functions. Now, this is a artificial neural network which could learn from examples of data thus train its network, which would then apply that learning to a new set of data. So if you see the network diagram that I'm showing here, you have an input layer to the extreme left and an output layer to the extreme right. And in between, there are multiple hidden layers. Now, each layer will have a certain function, certain action, and there is an interconnectivity between these, multiple layers through the nodes. And that is how different information which is stored in different layer is interpreted in the context of the other layers. Now, what is the artificial brain? Learning and adaptation. There is synaptic plasticity, which we have seen in the human brain. It strengthens or weakens synapses based on experience and learning, which means that my power requirement will almost remain constant, whether I'm doing a higher level function or a low level function. In AI, there is a weight adjustment. In AI model, learning involves adjusting the weights of connections through algorithms like backpropagation. And this process is guided by a loss function, which measures error and then makes a correction. There's a adaptive feedback loop that operates the AI function. Then we have parallel processing. Brain networks almost always do parallel processing, whereas parallel computation in AI helps in terms of neural networks which perform the same parallel functions, allowing them to process large amounts of data simultaneously. Then this is particularly true for CNNs, convolutional neural networks, used in image processing. Then we have specialized regions. In brain also we have specialized region. Different regions of brain specialize in different functions. Visual cortex for vision, motor cortex for movement, and so on. Similarly, in AI also we have neural network layers which do different functions. Different layers can specialize in different types of processing. For example, convolutional layers for feature extraction of images and recurrent layers for sequence data. So the entire AI is exactly modeled on how the human brain operates. We have further feedback mechanisms. In the brain, feedback loops to regulate and refine processes exist. For example, there is a sensory feedback helps to adjust our movements. We look and adjust our movements. So there's a feedback mechanism. And in AI, neural networks can use feedback mechanisms like recurrent connections to handle sequences and line-dependent data, time-dependent data. Techniques like reinforcement learning also involve feedback from the environment to guide learning. That comes from the artificial sensors and so on. A lot of information comes from the man-made sensors. So let's see, what is the concept of human-made intelligence now. Manushya swechhaya yastu yathartha samavapyate. Tasya prajna sampurna krutrimaha syad vikasitaha. The human through his own will, Manushya swechhaya yastu, attains the truth in its essence. Yathartha samavapyate. In him resides complete wisdom. Tasyaiva prajna sampurna krutrimaha syad vikasitaha. Artificially developed yet profound. So this actually tells you the role of human intention and creativity in developing intelligence vis-a-vis what is artificial. So we have spoken about some correlation between human brain, artificial brain, human sensors and artificial sensors, and so on. Now let's see what are man-made sensors. You have photoreceptors. For example, if I have to build an artificial system, I need a lot of data from sensors which measure the environment in various parameters. So I need to build man-made sensors, and the human being has several sensors which are a part of the human system. For example, photoreceptors. Human receptors are rods and cones in the retina. As against that, the artificial sensors are the digital cameras. They use charge-coupled devices, or complementary metal oxide semiconductor CMOS sensors. And light sensors are photodiodes and phototransistors. Now that is how the man-made sensors are built. Then you have mechanoreceptors. You have human receptors or tactile receptors, baroreceptors, proprioceptors, hair cells, and so on. When we come to artificial, there are pressure sensors, measure force exerted on surface, similar to the tactile sensor. There are change in resistance, change in capacitance, change in impedance, reluctance, and so on. So you measure that, calibrate that in terms of the measuring and so on. So you have artificial sensors. You have accelerometers and gyroscopes which detect motion and orientation. You have microphones that convert sound waves into electrical signals. Yeah, in thermoreceptors, you have cold and warm receptors in the skin and the hypothalamus, by which we know what is cold, what is hot, and so on. In terms of artificial sensors, thermistors and thermocouples do that job. And you also have infrared sensors. They measure thermal radiation to detect temperature variations, similar to how thermoreceptors function. So we have the human sensors. As against that, we have mechanical sensors, man-made sensors. Further, we have chemoreceptors. In human beings, gustatory receptors are taste buds. Olfactory receptors are for smell. And central peripheral chemoreceptors are there, which allow us to, feel the hunger, feel the pain, things like that. In terms of artificial sensors, we have gas sensors, detect specific gases in the environment, analogous to olfactory receptors. And examples include sensors for detecting carbon dioxide, methane, oxygen, and so on. We also have pH sensors, and we have electronic tongues. Use sensor arrays of sensors to detect and analyze taste, mimicking the gustatory receptors. Then we have nociceptors. In terms of human beings, we have thermal, mechanical, and chemical nociceptors. In artificial, we have damage detection sensors. For example, they are used in structures and materials to detect stress, strain, damage. And so therefore, we are trying to build something similar to what a human being has, but in terms of discretizing the whole human aspect. We also have electromagnetic receptors. They are primary theoretical in humans, but includes photo receptors for light detection and so on. There are many other specialized receptors. For example, osmoreceptors, baroreceptors, and so on. We have artificial sensors, humidity sensors, barometric pressure sensors, and things like that. So therefore, there is a complete effort at creating man-made sensors to measure almost everything in the environment. Now, this slide gives us consolidated view of what is measured. Hello? Hello? Hello?
Yes, sir, you're audible, sir.
Yeah, thank you. So we have in this table, the first column is measured, what is measured, which is the type of sensor, and what is the actuator that we have. So therefore, this table gives you a fair idea of how the man-made sensors are used. Now, having looked at all that, how is intelligence measured? First of all, we need to understand that intelligence is multifaceted. Hence, there are numerous tests. So mental age is based on intellectual development. Chronological age is the number of years that a person has lived. You take a ratio and you get IQ. And if that is in the range of 90 to 109, it means the IQ is average. This is just one test. There are multiple tests like that, Stanford Binet intelligence scales. And Wechsler adult intelligence scale is something that is used most often. It measures the verbal comprehension, perceptual reasoning, working memory, and so on. Now, besides these tests, there are multiple tests, achievement tests, SAT, aptitude tests, GRE, things like that, to measure specific aspects of human intelligence. Now, in terms of, again, going back to our philosophy, how does intelligence get measured there? Jnanam chittam cha viveka, guna sadhya parishilata, yatra sfurati samyaka, tatra buddhi miti jnata. Jnanam chittam cha viveka, knowledge, mind, and discernment. What is right, what is wrong? Jnanam chittam cha viveka. Guna sadhya parishilata. These qualities should be cultivated. Guna sadhya, they have to be cultivated. Where clarity shines brightly, yatra sfurati samyaka, samyaka is clarity, tatra buddhi miti jnata, their intelligence is truly measured. So there is a complete parallel and a contrast which we need to understand between how our ancient systems were interpreting and how the new science interprets. This emphasizes the importance of knowledge, discernment, and clarity in evaluating intelligence. Okay. The next is, So having defined what is human intelligence, now what is artificial intelligence? Coming back, how is it defined in terms of the science and so on? John McCarthy was the founding father, together with Alan Turing and various others. We all understand Turing, and part of cognitive science. Turing was the founding father of AI and modern cognitive science. He was an exponent of the hypothesis that the human brain is in a large part of digital computing machine. And what is that part of human brain? It's the cortex. He theorized that the cortex at birth is an unorganized machine that through training becomes organized into a universal machine or something like it. And AI is moving towards that universal machine. So Turing proposed the Turing test, a criteria whether an artificial computer can think, and so on. Very recently, to a couple of years back, we had the advent of ChatGPT, which we'll talk about in the applications of AI in education. This Turing test is extremely interesting. What does it do? It does not require the machine to be correct or logical in its responses, but rather to be convincing in stimulating human conversation. And the test is fundamentally about deception. And the key criteria is natural language processing. Machine must understand and generate human language fluently. That's the first requirement. Second is knowledge representation, which means the machine needs to handle and manipulate in knowledge to provide relevant responses, actually relevant responses. And the third is reasoning. Machine should be able to form logical reasoning, even if it is flawed, to sustain a conversation. Now that is required. Even if the logic is wrong, that's fine. But you keep the conversation going. That is the requirement of a Turing test. We'll just see on the bottom right, I have an example which says there is a judge. A typical Turing test requires 2 humans and 1 machine. 3 participants are required. So there is a judge and there is a machine. The judge should not be able to tell whether the person on the other side is a machine or a human being. Then the Turing test is complete. So the judge asks, are you a computer? Machine says no. The judge says multiply 2 numbers. The machine, after long pause, provides an incorrect answer. And then the judge says to add 2 numbers and the machine gives you the right answer. Now the judge is in a dilemma, whether this is a human being or a machine. So it has passed the Turing test. The next is, there are types of artificial intelligence. There is weak AI, and this is designed for specific tasks such as personal assistants, customer service, video games, questionnaires, and so on. It has limited algorithm and limited data source. And the examples for that would be Alexa, the Indian Railways as Disha, Apple Siri, these are all weak AI examples. In strong AI, it must be able to perform tasks that typically require human intelligence, and such as robots. There are other intelligent machines, and they sometimes afforded the same rights as humans. Now, what are the components of AI? For example, you have machine learning, which is a component of AI. A subset of AI that involves training algorithms to learn from and make predictions or decisions based on the data. So basically, essentially for predictive analysis. Within that, you have supervised learning, which is on a labeled data set where the desired output is already known from the beginning. In the unsupervised learning, the model is trained on data without labeled responses, identifying patterns and relationships. There is nothing known in the beginning. The third is reinforcement learning. The model learns by interacting with the environment, receiving rewards or penalties based on the actions. Now, the third part is the natural language processing. Ability is to understand, interpret, and generate human language. And the application is language translation, sentiment analysis, chatbots, and voice recognition. The sentiment analysis is something very interesting. Let's look at one example later. So if I have to diagrammatically show the evolution of AI is the science and engineering of making intelligent machines. That is how we started off with. We got a subset, machine learning, which does some prediction. Deep learning is a part of machine learning, an advanced branch of machine learning, which can look for patterns and look for, generate new information, things like that. And out of that, what is generated is what comes out is the generative AI, which is an advanced branch of deep learning. So these are the four steps in the evolution of AI and how it has moved. And all this has happened with the understanding of the human brain in more and more, once the human brain is understood more and more, you understand AI more and more. So computer vision is an application, robotics is an application, expert systems is an application, deep learning is an application. Now, like I said, deep learning is a subset of machine learning involving neural networks with many layers. That middle layer that you have seen, there is an input layer, there is a mid layer, there is an output layer. The mid layer is actually multiple layers, multiple mid layers involving neural networks with many layers, deep neural networks that can learn complex patterns in large amounts of data. Now, applications are speech recognition, image and video analysis, and natural language processing. Now, this is what happens in the ChatGPT and the generative AI. Now, what are the applications of AI? Healthcare, medical imaging, drug discovery, personalized treatment plans, virtual health assistants, finance. Within finance, you have fraud detection, algorithmic trading, credits scoring, customer service, transportation, autonomous vehicles, traffic management systems. SCADA is a great example of traffic management systems, which uses a lot of AI. Retail, personalized recommendations, inventory management, entertainment, content recommendation systems, video games, and automated content creation. Within manufacturing, you have predictive maintenance, where again machine learning comes in, quality control and supply chain optimization. Within education, you have personalized learning platforms, automated grading, and administrative automation. Now, putting AI and several other technologies together, for example, 5G, DevOps, blockchain, cybersecurity, we build something called as Industry 4.0. So let's look at how Sanskrit and AI, what is that interface, and how do we recognize the context? Dharmakshetre Kurukshetre Samaveta Yutsavaha Mamakaha Pandavaschaiva Kimakurvata Sanjaya. Dharmakshetre Kurukshetre Samaveta. In the field of righteousness, Dharmakshetre, Dharma is righteousness. Kurukshetre, in Kurukshetra, Samaveta Yuyutsavaha. Samaveta, establish yourself, O Pandava. Mamakaha, hence arise Pandavas Chaiva Kima Kurvata. What are you doing? You rise and do your duty. Now in this shloka, there is a context in every language. And if we remove the context, that language becomes meaningless. Now these texts were written many thousands of years back. Now what it means that we need to create the context in order to understand the language which was written at that time. Can AI help in doing that? Now that is what is called sentiment analysis. And the shloka encourages individuals to pursue the goals and strive for greatness. And this is the basic understanding of this shloka. There are multiple contexts available to this shloka. Now, when this shloka was input to an AI algorithm, its meaning and context of words was analyzed in different structures, in different contexts. Different contexts were created, allowing AI to make predictions and draw conclusions about the text. So you get multiple interpretations of the same shloka, and you need to put together which context is useful at what time. And whether the context that we have created in Bhagavad Gita is the context that we are actually interested in. Now, one of the key applications of Sanskrit in NLP and AI is the sentiment analysis, which I said. This involves analyzing large amounts of text data to determine the overall sentiment or emotion expressed in the text. How do I capture the emotion of the text which was written 5,000 years back? That's the problem. Sentiment analysis algorithms, they can be trained to recognize the complex emotions and concepts expressed in Sanskrit shlokas. This allows the algorithms to identify not only the positive or negative sentiment of a particular text, but also the specific emotions and sentiments that are being expressed. So there is a research work that is going on around this concept, and there are various shlokas which I have in my presentation. I have cited some shlokas. They are all the shlokas for research in the sentiment analysis. Now, this is also an important tool in fields such as marketing, customer service, and politics, where understanding public sentiment is crucial. As much as I can apply it to Sanskrit text of 5,000 years back, I can also apply it to understanding my customer, understanding the marketing requirements, and also understanding the people's sentiment while they are voting for a certain candidate within the realm of politics. Then I have another area where Sanskrit is used in natural language processing and AI is in the field of machine translation. There are two things. There is a transliteration and there is a translation. Transliteration is easier, where you try to, just say the meaning of the words by word, but it may not convey what it actually is supposed to mean. But in translation, machine translation is extremely important, where if you can also capture the context and the emotion built into that statement, which may have been written many years back, that is required. So it uses algorithms to translate text from one language to another. In fact, ChatGPT is available in 18 different languages. It can understand 18 different languages. Though I tried some of them, but the context and the meaning in machine translation between certain languages is completely lost. So this is a complex task, as the algorithms must be able to understand the grammar, vocabulary, and meaning of this source language, and then translate them into a target language. Many times, the words that we use in a certain language mean something in that language and mean something else in a different language. So how do we correlate that becomes extremely difficult, complex. Then multiple shlokas have been used in AI from the Katha Upanishad, which state that the ultimate reality is beyond human comprehension and that it can only be understood through intuition in order to explain their intent. Now, the difficulty here is the Katha Upanishad has several anecdotes, several contextual statements, which are beyond human comprehension, and it actually tells you what is the current life and what is the future, things like that. So a lot of it depends on the intuition and how do you understand the text of within the shloka. Another important Sanskrit shloka used in natural language processing is the Gayatri Mantra. Now, this shloka has been used in NLP to study the sentiment behind religious texts. That is very difficult to do. Researchers have analyzed the sentiments expressed in this shloka and found that it conveys a sense of devotion and reverence. But beyond that, what does the inherent contextual understanding of Gayatri Mantra would be, that would be interesting. And the research is currently around that concept. It's not that it shows devotion or reverence. One should be able to go to the next level of contextual understanding of Gayatri Mantra. And how does it affect the human brain? How does it affect the various frequencies at which human body operates, different parts of human body operates, and so on. And whether it has some relation to human frequency and things like that. The frequency at which the earth expands and contracts and so on. So a lot of research is happening around these areas. Now, if I go further into the applications that are possible, there is a history of chatbots. In fact, AI was first, the first chatbot came in 1963, many years back. And Joseph Weizenbaum was the professor in MIT who developed ELIZA, but with a very limited, conversational possibilities. It's a chatbot which can converse with human beings. So you type in statements like, how are you? It will reply back saying that I'm fine. So things like that. Then the next level was Parry. The next was Alexa, Cortana, and ChatGPT. So that is the evolution of the chatbots within AI. Chatbot, again, we all know, OpenAI, proprietary, generative pre-trained transformer models, fine-tuned, and it has supervised learning, reinforcement learning from human feedback. What are the examples? We have Bard of Google, Copilot, Perplexity AI, and many others are examples in that ChatGPT model. It's not only the OpenAI that's available as a ChatGPT AI model. What is the architecture? It's built on the transformer model of architecture. The way the multiple layers are built in to create the, the transformer, its reluctance and so on. Then we have, the training and the capabilities. It can perform various language tasks such as answering questions, providing explanation, generating content, translating languages, trained on a diverse set containing vast amounts of text from the internet, allowing it to understand and generate a wide range of topics and contexts. And different contexts pertaining to different data sets are built into different layers in that multiple layer stage. What can it do? It can offer innovative applications in education, enhancing learning experiences, educational processes. It makes education more accessible, personalized, engages stakeholders, natural language processing capabilities, acts as a virtual tutor, provides personalized assistance to students based on their individual learning needs, provides homework assistance 24/7 by 365, assists in language learning by engaging students in conversations in the language they are trying to learn. For example, some of you must have used Duolingo. It's a not a very high level AI model, but it helps you learn languages. It helps you correct grammar, suggests vocabulary, and provides cultural context, enhancing both written and spoken language skills. Then you have interactive simulations and role-playing scenarios. It helps in preparing for exams. Teachers use it to generate educational content. Researchers find relevant information, collate research papers, generate hypotheses, and so on. And in online or blended learning environments, ChatGPT can facilitate discussions by moderating the forums, posing thought-provoking questions, and ensuring that conversations stay on the subject. And it helps maintain effective communication. This is what ChatGPT can do. There is a flip side for everything that we do. We'll look at the flip side as well. What does the ChatGPT, what can it not do? It cannot provide emotional or social support, cannot fully grasp complex critical thinking and creativity often required in understanding logic, cannot provide practical skills, hands-on learning, does not possess a sense of ethics or morals, cannot make ethical decisions, cannot provide personal emotional feedback, cannot make informed decisions, cannot build long-term mentor-student relationships, cannot solve complex problems that require deep domain expertise, can struggle with contextual nuances, where I have said, like you give a shloka and try and figure out the meaning of that in a context in which it was written, that a ChatGPT will not be able to do. And it cannot handle sensitive personal information. So what do people do? Come generative AI. Now, many of these things that ChatGPT cannot do are addressed in generative AI. What are the challenges and ethical considerations? Bias and fairness, transparency and explainability, privacy, job displacement, autonomy and control. These are challenges, and there are ethical considerations as well. Now, one of the most important ethical consideration is, now, what happens to originality? Now, if I have a model which can help me gather, material from various primary sources, secondary sources, and so on, a job that I used to do in maybe 6 months' time or a year's time, my literature survey, it gets me all the information in probably half an hour of intelligent question posing on ChatGPT or maybe generative AI. So how does and then it also helps me to do a gap analysis. It also gives me the tools to, extrapolate, interpolate, and so on. And so therefore, what I produce now, can I actually call that as mine? Now, so therefore, there is a question of what is originality, or is it only the future knowledge is only reduced to using the tools to generate new knowledge. So don't call it original. Is that the way we are going? So what is generative AI? It's capable of creating new content, whether it be string, character, integer, float, Boolean, text, images, music, or any form of data, based on the patterns and structures it has learned from the existing data. Now, this is absolutely, amazing. Unlike traditional AI, which typically focuses on recognizing patterns or making decisions based on predefined rules, generative AI aims to generate novel and original outputs. Now, this creates much more problem in terms of creating new research, creating new knowledge, and so on. And the NLP capabilities give you a document which will be extremely difficult to figure out even with the best of the anti-plagiarism tools. Now, what are the key components? There is a training data that is required. Generative AI model, obviously, you need very large data sets. Encompass the type of content they are expected to generate. For example, text generating model like GPT-4 is trained on vast amounts of text from books, articles, websites, and other sources. And everything that I ask a question and generate a data through ChatGPT or GPT-4, generative AI, what happens is my information is being added to the database. Now, this is another ethical consideration that we must look at. So tomorrow, what does it produce? Does it produce from whatever I have input? These are the questions. Latent neural networks, the backbone of generative AI is usually neural networks, particularly deep learning models like transformers, which can learn complex patterns in data. And latent space, this is important for generative AI. It's an abstract multidimensional space where the AI model represents the features of the data it has learned. And by navigating this space, the model can generate new data points that are similar to the original training data, but are not exact copies. This is where a Google search is, or your generative AI is different from Google search. The latent space makes it different. You also have generative adversarial networks. They consist of two networks, a generator and a discriminator, that work in opposition to improve the quality of the generated data. The generator creates new data samples, while the discriminator evaluates them for authenticity. In fact, creativity can be looked at very differently. I mean, if I do something differently than what is being done, people may call me creative. But assume for a given problem, or for finding a solution to a given problem is important. But creating a problem from an existing solution is also creative. And then you try solving that problem, you get to understand different facets of creative thinking. How is AI measured? We have seen how human intelligence is measured. Now we'll see how AI, artificial intelligence is measured. It involves evaluating performance, capabilities, and impact of AI systems. And it's done through metrics, tests, and methodologies tailored to the specific types of AI and its intended application. One is performance metrics. It tells you accuracy and error rates. So what should be the answer? What is generated? What is the gap, or what is the error? Things like that. So accuracy, error rate is something that is measured. It's a mean squared error for regression tasks or analysis. Then you have precision, recall, and F1 score. Precision is the ratio of true positive result to the total predicted positives, measuring the accuracy of positive predictions. Then recall is the sensitivity. How many times can you do the same thing in relevant instances? Then F1 score is a harmonic mean of precision and recall, providing a single metric that balances both of them. And then fairness and bias is the human-AI interaction. Now, besides these methods of measurements, you have benchmarks and standardized texts. So, in terms of our philosophy, Hindu philosophy, how do you measure intelligence? Viveka samyak attishtet jnanamekam pravardate sadhanani cha yatra buddhis sampadaya manata. Viveka samyak attishtet, discernment. Viveka means intelligence or ability to know the right from the wrong. Samyak attishtet should rise with clarity. Jnanamekam pravardate, knowledge alone flourishes. And where the means are gathered well, sadhanani cha yatra tatra, wherever the means are gathered well, buddhi sampadaya manata, their intelligence is recognized. That is how the philosophy measures intelligence. You should be able to discern, you should be able to rise with clarity, and you should be able to collate the information that you have, which all becomes your intelligence. So it highlights the role of discernment and knowledge in assessing intelligence, along with the importance of effective methods. Now let's come to AI in education. This is revolutionizing education by enhancing learning experience, obviously personalized learning. It enables the creation of customized learning experiences tailored to individual student needs. Adaptive learning systems. See, we have an open control system where we don't know whether the process is giving me the right output or not. It's an open loop. We assume that the outcome is as per what we desire. In the closed loop, you measure the outcome, add it to the input in the next cycle, and then over a period of time, the values may converge to something. But that time will be large. The system, the time for stabilizing the system will be much larger in a closed loop system. So therefore, you have adaptive learning systems where you go by component in a system and figure out what is the input to that component and what is the output of that component, and correct the component level functions. So they adjust the difficulty of lessons based on the student performance. So you don't teach him the entire chapter and then figure out whether he has learned or not. But what you do is you break the chapter into smaller units and you create an adaptive mechanism around each unit. And then that is how the learning progresses. And then you have intelligent tutoring systems like Carnegie's learning material provide real-time feedback and one-on-one instruction, helping students understand complex concepts. Within the personalized learning, you have 5 steps: testing, learning, teaching, exercise, and testing. So you have the first one is a pre-testing. The learning, you decide what learning the student has, then you teach, then you give exercise, then you test. So there is a knowledge domain module, there is a teaching module, and there is a learner module. In fact, most of the learning LMS platforms use all these methods, whether it's campus or what is it? Campus is one of the major LMS that is available. Then there is Microsoft models available, and so on. Now, administrative efficiency, it can increase. AI streamlines tasks, allowing educators to focus more on teaching. And the key areas are automated grading, administrative task management, and enhanced engagement and gamification. We all know every LMS and ERP combined together can do a lot of streamline a lot of administrative tasks. Automatic grading is another for multiple choice tests and essays. There is GradeScope, which is an application which uses machine learning to assess student work and gives a feedback, immediate feedback. And you have AI tools that create interactive and engaging learning experience through various methods. Then gamification is important. It can integrate gamified elements into lessons, making learning more engaging. For example, in the olden days of Shankaracharya, we had 4 matas that were created by him, and there are certain learning pedagogies and andragogies that are still being used in those matas even today. For example, he uses several pedagogies which are your Upadesha Vidhi, or your Shravana Vidhi, or Adhyaropa Apavada Vidhi. These are some of the Vidhi means is a method, and in teaching the students, they use various pedagogies to make the students understand the philosophy behind the various shlokas that they use. So therefore, they also teach the method of going from reality to unrealistic situations, coming back from unrealistic to realistic situations, and so on. So there are many such things that are happening, and from an education perspective and from an AI perspective, we must build those methodologies and create new learning paradigms. As far as game is concerned, we know children are hooked onto video games, but when they are given even a 15-minute education module, they find it very difficult to concentrate. So what is it that puts them on to a video game and not to education? So there's a lot that can be learned from how games are created. So bringing gamified elements into lessons, making learnings more engaging, and so on. So Kahoot and Classcraft, they use AI to adjust game difficulty and provide personalized learning paths. UNESCO has note which a document which they have created for mentioning how generative AI can be used in teaching. Now, for those who are interested, this presentation I can share with the professor, and you can look at the details. This chart shows how generative AI can be used in research. Again, a UNESCO document. So you also have virtual and augmented reality, your predictive analysis, early warning systems. AI can predict which students are at risk of falling behind. For example, systems like Bright Bytes analyze attendance, grades, and engagement to flag at-risk students early enough for corrections to take effect. Then you have learning analytics, Blackboard, Canvas. These are all the high-end LMS, which I believe the institutions should have, so that they make the best use of AI in education. Language learning can be facilitated through interactive adaptive platforms. Duolingo, which I have already spoken to you, can personalize lessons. Speech recognition, AI-driven speech recognition like Google's speech to text is an application. It assists in language pronunciation and conversational practice. AI also increases accessibility and inclusion. People with disabilities, people with special requirements, they all can be helped using AI in education. Assistive technologies, AI-powered tools such as text-to-speech, natural reader, speech-to-text applications, they help visual or hearing impaired students. AI can create personalized learning plans. They can help in professional development. Personalized training programs can be created. For example, AI-driven platforms like Coursera, edX, or Udemy, they offer personalized course recommendations based on teachers' interests and career goals. And then performance and feedback. Many of these LMS tools, they also give you instant feedback so that the student learning cycle can be corrected online. Of course, AI can also be used in content creation and curation. New content can be generated because of tools like chatbots like generative AI. And then resource curation. AI platforms curate educational resources from various sources, which will be very difficult for a human being to do, providing educators with relevant materials. IBM's Watson Education is a good example of curated content. Then again, some UNESCO documents, emerging technologies in education to pair with AI. There is technology, description, and value for education. What virtual reality can do, what is virtuality, what it can do, and what is the value that it brings to education. Similarly, AR, similarly, IoT, Internet of Things. And then what is generative part of AI in edu? You can generate text, you can generate images, music, audio, video, design, prototyping, and so on. So there will be some amount of creativity that you create using generative AI. Efficiency will be much better because a lot of automation can happen. And personalization can happen. You can tailor the content, the material to what a student requires based on his mental abilities. So now, having looked at intelligence and education, how do we relate education and intelligence? How do we relate them together? Viduraniti says, Uddhareda Atmanam na Atmanam avasadayet Atmaiva Hayatmano Bandhuratmaiva Ripuratmana. Uddhareda Atmana. A person must uplift their own self. Uddhared Atmanam. Atmanam na Atmanava. How do you uplift self? By their own effort. By their own effort. And should not degrade themselves. Atmanam avasadayet. Atmano, the self or mind. Bandhuratmaya, it can act as a friend. And Ripuratmana, it can also act as an enemy. So a person must uplift their own self by their own effort and should not degrade themselves. The self or the mind can be a friend, it can be an enemy. It is up to you as to how you do that. So therefore, education and intelligence are completely correlated. This is again AI in education. How do you implement? There are a lot of things I have said today. How do we actually go about doing this? That will need another separate session where you draw the curriculum maps and how do you generate the course outcomes, the program outcomes, how do you relate them, how do you then build the content, what would be the prerequisites, what would be the core, what would be the value addition. Now, all that is a part of AI implementation strategy. There is again a UNESCO document that says assessment, planning, and monitoring. Now, how do you assess? How do you plan? How do you monitor? Then you have, this is a case study which they have used in Georgia State University. They have used AI to build various systems to do their academics, do their administration, and so on. Now, what are the future directions? Developing AI that can perform any intellectual task that a human can do rather than being limited to specific tasks. We are today limited to specific tasks. Can there be a system that can do anything that the human being does? That will be a part of, unsupervised learning and semi-supervised learning and applications of that, and so on. AI ethics and governance, creating frameworks and regulations to ensure the ethical use of AI to address bias, privacy, and accountability. Then you need to integrate with other technologies, combining AI with Internet of Things, blockchain, quantum computing to create more powerful and integrated systems. Once quantum computing comes in, cognitive computing comes in, things will change drastically. The way we think, the way we operate, the way we calculate, the way our systems interact with, the environment, everything will change with quantum computing and cognitive computing. And then through a combination of vision, sensors, cameras, a lot of real world applications can be built. Then, I'll just take about 5 minutes more. Then we have a lot of intelligent machines. There are challenges and considerations, like I said. Most of the concerns are around the quality, ethical concerns, computational resources, and so on. This is again one more UNESCO chart which says AI in education. What are the challenges and how do we overcome those concerns? This is the final slide that I have. We are ultimately, whatever we do, there is human intelligence, there is artificial intelligence, and there is a correlation with the philosophy that we understand. This is what I have tried to show. But ultimately, we are all highly limited. Anantam Vishwam Akasham, Visrunjyemam Vilokayanatam, Na Madhyam Na Punastavadim, Pashyami Vishweshwar Vishwarupam. Anantam Vishwam Akasham. I see you infinite in every direction. This is the Vishwarupa when Lord shows to Arjuna. Visrunjyemam Vilokayanatam. O Lord of the universe, in whose form is the entire universe. You are the entire universe. Any direction I see only you. I do not see the end, the middle, nothing I see. Na madhyam na punastavadim. And Pashyami Vishweshwara Vishwarupam. I see the universe, you everywhere. Now, that being the reality, what we do in artificial intelligence or whatever, it can only be limited. So therefore, we need to understand that there are powers uh, much higher, at a higher level than all of us. And going towards that is possible, but reaching that and becoming one of that is possibly extremely difficult. These are some of the useful references that I've used in case anyone used. And then this is my slide where you can reach me. And thank you. So this is, I have come to the end of my presentation. I hope people have, looked at the nuances that are brought in between the human and the artificial intelligence part and how it correlates with the philosophy that we understand. Thank you so much for the opportunity.
Hey, thank you so much, Professor Mantra, for your excellent lecture. And for your information, Professor Mantra, every Saturday, he gives actually a lecture on YouTube and you can access it. Also, he contributes to Lokmat Times on topics of interest. Some of you may think of. Even today, he's writing in Hindu as appeared today, an excellent writing. So from Professor Mantha, a lot of things actually we could learn, and many basics, many doubts, a lot of things actually he clarified. I'm sure all of you must have really enjoyed his talk today, and particularly his depth of knowledge, both in actually Sanskrit slokas and from different texts. At least he should have appreciated. With these few words, may I now request all of you.
I am going to hear you.
Yes, sir. Sir, please. The professor is past chair IEEE.
Hello, everybody.
Yes, sir.
Hello, sir.
I think when you hear a lecture like this, there will be a lot of doubts in your mind. I personally feel that this AI thing is a one-way track, that if you can enter easily, what coming out is difficult. A worldwide application of generic AI and leaving your decisions to AI to solve all your problems is ruled out. I think one example I will give. Recently, I read an article that AI tells that Lord Krishna lived for 189 years and he fought the war when Bhima was 95, Arjuna was something like 85. And so I was thinking that if we are jousting your intelligence in finding this kind of conclusion in AI, if it is true, then what benefit it gives to the society? So how do you check the misuse of AI? And how do you say that a common man knows exactly how much and what AI will benefit him? I heard you talking about education and all. Intelligent faculties are able to do that without AI. And the institute pays a huge amount of money to implement or introduce AI. And does it really serve the students at the end of the day? In your opinion, please.
Sir, you have asked a very pertinent question. Most of the problems that we solve in science and engineering are based on the assumptions that we make and the boundary conditions that we create. Now, if the assumptions are right, then the answer that we get probably converges to what is the truth. Now, if somebody, I mean, looking at the looking at a problem by omitting the context is probably not the right way to do. So therefore, what I feel is, instead of commenting directly on those kind of examples, it's necessary, very necessary, to understand what was the problem that was created and what were the inputs that were given, and what were the assumptions made and things like that, and what was the context created at that point of time. So if those things are right, then probably what see, all that we can, there is nothing like a definitive answer to these questions. It's only a conjecture. Now and all the conjectures depend on the assumptions that we make. So if the assumptions are right, probably the answers would tend to be right. I mean, that's how I look at it, rather than saying whether a certain problem that happened 5,000 years back, whether it really, is right in today's context. We all understand the problems in a certain way today. They may have been executed in a very different way then. So unless we capture that essence, it's not possible to answer those kind of questions. If somebody is doing it, they must be doing it for, as an academic exercise, maybe.
Okay. Yes, sir. Yes, sir. Yes.
You are mute.
Sanath sir,
Sanath, you are mute. Please unmute, then ask your question.
Yeah. Can you hear me now?
Yes.
Yeah.
Please.
In my line of work, I would like to use AI for troubleshooting. So I have a system where there are hundreds of actuators and probably thousands of parameters. Now I can do a brute force method, draw a chart, every parameter, every actuator, find out and then say what is mistaken. But that is too much. So is there a possibility that AI will use heuristic methods and then say, okay, this is likely to be the cause? At least, 2 or 3 causes it says. Then we can put our mind on those and at least knock off something and take off something. Is it possible? Has it such a thing? Does it exist?
Yeah. First of
And
all,
I got another question. May I ask it now itself or later?
no, I will. Yeah, I'll answer it right.
Okay.
The simple answer is yes, it can be done. Now, how can it be done? I'll give you an example. When you go to a Google search engine and you want to find out something, about something, and in almost a few fraction of seconds, it gets you all the information. Whereas, where is that information? How has it been sorted? Things like that. Questions are there. So therefore, there are several machine learning algorithms. There are genetic algorithms which can find out, based on the truth tables that you create, you can actually figure out much faster what the solution for your problem. It's perfectly possible. We need to understand the problem in its completeness, and so on.
That is the issue. Anyway, the second question is probably trivial. Supposing the slokam that you said, Dharma Kshetre, Kurukshetre, Samaya, you said that.
Yeah.
Now, supposing it is an unseen, unknown text to the AI fed for the first time, can it tell who was the person who asked this question? Who was the person who looked at the situation? Who was the person who is the commentator? And why was he asking? Is it possible for it to find the sentiment of that?
No, unless you build the correct constructs, and unless you build the characters in the story, it will not be able to do. But what it can do is what in general that shloka would mean, in a certain context. That's what it does. It cannot probably pinpoint it to a person who has actually said that.
Okay.
Unless
Thank
you
you, sir.
create data sets and suitable constructs to for it to make some assumption and tell you.
Okay. Thank you.
Thank you.
Any other question?
Oh, one more doubt, Tripathi here. Sir, in the 70s and 80s, we were talking of expert system. That was the artificial intelligence, whatever we knew about it. For example, when you are working in a steel plant, somebody who is an expert and who has got 30, 40 years experience, his knowledge is captured in a particular way so that that data bank is built and it continues so that you can advance conclusions you can draw, even if the person has retired. So that system is the basic. Even today, when you apply the AI, the expert system build up and the right data support is required, I believe. When suddenly I thought in the 90s and 2000, the computer engineers came and diverted the attention of data planning and data storing and data retrieval to something like computer languages, cognitive science and all that. Are we not losing focus on the fundamental?
No, fundamentals will always remain the same. We don't lose focus. What has really happened is the enormous amount of computing power has given you a lot more possibilities. And the data, the real-time data that you get from various sources can be, mined, can be stored, can be mined, can be used to create different patterns, different, solutions which you probably may not have thought of at those in those times. So therefore, the primary focus will never change. The ability to figure out more possibilities will certainly be there.
Right. Agree.
Okay. Now may I request all of you to just switch on your video so that we can take a photograph. Please. Professor Mantha, may I request you one thing? Because your lecture has been fully recorded. Do you mind it that that it should not be shared with anybody, or it can be shared with?
Absolutely none, sir. You are
We can share.
absolutely free to do what you want to do with it.
Okay. That is great.
It will be my pleasure to reach it out to as many people as you want.
Okay. Thank you. Now may I request Madam Renu Sharma to please propose a vote of thanks.
Yes. Good evening, everyone. On behalf of Indian National Academy of Engineering Bhubaneshwar chapter, Shiksha Anusandhan Deemed University, CSIR IMMT Bhubaneshwar, IIT Bhubaneshwar, NISER Bhubaneshwar, and IEEE Bhubaneshwar subsection, I feel privileged to deliver the vote of thanks for today's enlightening session, sir.
Thank you, Acharya ji, and thank you all the other participants. Thank you.
Thank you so much.
Thank you.
Please.
Mind-boggling.
Thank you, sir.
Am I audible, sir?
Yes, you are audible. Please go ahead.
Okay. So first and foremost, I extend my heartfelt gratitude to Dr. Shankar S. Mantha, sir, Chancellor, RB University, for his remarkable presentation on application of artificial intelligence in education. Sir, the insight and the experienced way of presenting and shedding the light on the profound potential of AI to transform the educational landscape, empowering both educators and learners to achieve new heights. Especially the sentiment analysis algorithm can be trained to recognize the complex emotions and concept expressed in Sanskrit sloka really touched my heart. This allows the algorithm to identify not only the positive and negative sentiments of a particular text, but also the specific emotions and sentiments that have been expressed. I'm also very much touched by various shlokas which were interpreted, well connected with the AI and demonstrated well by you, sir. Thank you, sir. And also, I would like to thank Honorable Professor Damodar Acharya, Chairman IEEE Bhubaneshwar chapter and also thank him for his continued leadership and vision for this chapter. We also express our sincere thanks to Honorable Vice Chancellor Professor P.K. Nanda Sir, SOA University, directors of IIT Bhubaneshwar, CSIR, MMT Bhubaneshwar, NISER Bhubaneshwar, and past chair IEEE Bhubaneshwar subsection Professor A.K. Tripathi, who was continuously, they were attending this, and who their invaluable contribution have always been the source of inspiration for all of us. I would also like to acknowledge the esteemed fellows, INAE, and the members of INAE who have graced this occasion being present over here. Sir, your active participation underscored the importance of today's topic and shared the commitment as we all today advancing in the field of engineering and technology. Finally, I give my thanks to all the faculty, students, and staff who have attended today's webinar, a seminar, a distinguished lecture by Honorable Dr. Shankar S. Mantha. Thank you, sir, once again on behalf of Hosting Institute and Collaborating Institute. Thank you, sir.
Thank you.
So, Professor Mantha, if you do not mind, actually we'll send a small memento to you. We cannot compensate in anything, but at least a small memento definitely will send. Thank you so much.
Sir, I have great respect for you. So, for a small time, we did work together. But yes, I mean, I would only say thank you for inviting me.
Thank you so much.
Thank you.